Hello, welcome to the week 5 of the recitation class for EE2423 network theory. So I know that in the last week you have finished with your exams, and today I will be solving couple problems on two simple circuits. And as usual, if you have any questions on the course, anything related to the network theory, then you can directly ask me. You can send me email, or you can come to my office hours. So I have office hour every week. It's on every Tuesday on noon at noon until 2 p.m. All right, so let's start with the problem number 1. Okay, so in these two problems we are still working on how can we use a node voltage technique to solve pretty much simple circuits. And this is the first circuit that we have for the first problem. So I have a voltage source 144 volts, okay, and it is connected to a resistor 4 ohm, another one 10 ohm, 80. We have a current source 3 amps, and the last resistor 5 ohm. Okay, and the question here is simple, so find the voltages V1, V2. Okay, so it's a pretty simple problem, and let's use the node voltage method to solve it. All right, okay, so solution. When you are working on a circuit, the first thing is that you have to define the reference, right? So let's put ground on here. So this ground provides us with a voltage reference. So we can say that at this ground the voltage is 0. Okay, so what is the voltage? Maybe that's why we can say that the voltage here is V1, voltage there is V2, but because we have 0 here, right? So this point here, if you measure this point with respect to this, it will read as V1, this one will read as V2. But if you want to measure the voltage across, say, this 80 ohm resistor, then the voltage will be V1 minus V2, because here what the reference here is V2, right? One is your voltage with respect to the other, because voltage you need two terminals when you are measuring voltages, right? So you need two terminals, one is positive, the other is negative for DC, and that's why you always need a reference. Okay, so here if you want to measure the voltage across this 80 ohm resistor, then you will put your meter here on the V1 and the other is on V2, two terminals, and the voltage reading is V1 minus V2. All right, similarly here in 5 ohm resistor, then the voltage will be the same as V2, right? Because you have V2 there, which is connected to here, so here still we have V2, but with respect to what? So V2 on 5 ohms is measured based on this point here, but this point here is connected to the ground, which is we assign it as 0. So that's the like one of the purpose of why we have a ground, which is the purpose here is to provide us with the reference. Okay, if that is clear, then let's apply the node voltage. All right, so how many nodes there? We have two, right? These nodes, 1, 2. Okay, so let's do the node voltage on the first node. So in node voltage, we are measuring, essentially we are using the Kirchhoff current law. So any currents uh, on one particular node, so the sum of currents going in or going out uh, on a particular node should be zero, right? So in node voltage, we define the current as, so the direction of the currents are going out from that node, right? So this is for node 1 and this one is for node 2, right? So the sum of these currents should be zero based on the Kirchhoff current law. Okay, so what is this current here on the red arrow here? So it's going from this node to the 144 volt voltage source, right? So this current here is V1, right? V1 minus 144 over 4 ohms, okay, plus the next current here, so V1 minus 0, so you just have V1 over the resistance there, 10 ohms, plus the current here flowing through the 80 ohm resistor, so the current there is V1 minus V2 over the resistance, and the sum of these currents is 0, right? The sum is 0. So basically we want to work this out. So let's simplify this. So the obvious way is to multiply the both sides of this equation here with 80, right? So you can multiply both sides with 80. We get 80 over 4 is 20. V1 minus 144. 80 over 10 is 8. V1 plus V1 minus V2 is 0. Okay, you can simplify it further. So 20 V1 plus 8 V1 plus V1, you get 29, right? V1 minus V2 is 20 times 144, right? So 2880. Okay, let's call it the first equation. Second node, we have, so this current here is the opposite of that current there, which is this one. So for the second node voltage equation, we get V2 minus V1 over 80, right? Plus the current going through that direction from the V2 to the ground, but the direction of this current is opposite to the direction of this current source, which is 3 amps, right? So we just write minus or negative 3. So then the last one is V2 over, so V2 minus 0, you have to get that ground over 5, which is 0. Again, you can simplify it, multiply by 80. V2 minus V1 minus 240, so 3 times 80 is 240, and 80 divided by 5 is 16, so plus 16 V2 equals 0. We get minus V1 plus 17 V2 equals 240. So that's the second equation. Okay, so you have two equations. We have, this should be V2. We have two equations, we have two variables, so we should be able to get a unique solution. All right, so you can use substitution, but I prefer to solve it using matrices. So let's write the equation uh, into a matrix form. So you have 29 minus 1 minus 1 17 v1 v2 equals 2880 240. So you can multiply with the inverse of this square matrix, right? So v1 v2 is equal to 29 minus 1 minus 1 17, and this matrix inverse multiplied by 2 8 80 240. Okay, so you know the inverse of this matrix, so you can compute it. Should be equal to 0.03. I think it's 346 if I'm not mistaken. 0.002 0.002 0.0589 multiplied by 2880 240. Okay, and you will get, so 0.0346 multiplied by 2880 plus 0.002 multiplied by 240, so that will give you v1. The same thing, this 0.002 multiplied by 2880 plus 0.0589 multiplied by 240, and you will get v2. So simply I get 100 volt there and 20 volt here. Okay, so we get v1 is 100 volts, v2 is 20 volts. Okay, so yeah, so the question is find v1 v2. So v1 is 100 volts, v2 20 volts. So those are the answers for the first problem. Next one, the circuit is given as follows. It's a very similar circuit, but just with different values. We have another voltage source, 44 volt. We have 4 ohm, 6 ohm, 1 ohm, 3 ohm, 2 ohm, and voltage source 2 volts. Okay, here the following currents are defined. Call it IA, IB, IC, ID, and IE. Okay, so the first question, so question A, find IA, IB, IC, ID, and IE. Second is compute the developed power. Okay, again we can use the node voltage. We have 2 nodes. First node, let's call it v1 again and v2. Solution, first let's put the ground, and let's apply the node voltage. on the first node there. Again, node voltage is defined for current going out. Okay, so these are the direction of the current for the node voltage analysis. We have on this node V1, we have V1 minus 44, right, over 4 plus V1 over 6 plus V1 minus V2 over 1 equals 0. To simplify this, let us multiply it with 24. We have 6 V1 minus 44 plus 4 V1 plus 24 V1 minus V2, right? And you can simplify it again. We get 6 plus 4 plus 24 is 34 V1 and minus 24 V2 equals 264. So that's the first equation. The second equation is on this V2 node we have V2 minus V1 over 1 ohm plus V2 over 3, right? And the last one is V2 minus, notice that the voltage sign on this voltage source is flipped, right? You have negative there instead of positive, so minus 2 over 2 equals 0. To simplify it, we can multiply this equation with 6. We have 6 V2 minus V1 plus 2 V2 plus 3 V2 plus 2, right, equals 0. So we have minus 6 V1. 6 to 3 is 11 V2. 3 times 2 6 minus 6. Second equation. So we can write into this form using matrix 34. So we want to find V1 V2, right? Minus 24 minus 6 11 V1 V2 264 minus 6, right? So V1 V2, again you need to invert this matrix 34 24 6 11 inverse 264 minus 6. V1 V2, so I got 0 4 7 8 2 6 1 1 0 4 3 1 4 78 2 6 4 minus 6. V1 V2. So again you can multiply this matrix with this vector 12 6. Okay, so we get V1 is 12 volt, V2 is 6 volt. So the first question is what are the values of these currents? So let's compute that IA is defined as the current going to that direction on this 4 ohm resistor. So IA is 44 minus V1 over 4, right? But V1 is 12, so 44 minus 12 over 4 is 32 over 4 is 8 amps. IB is I1, right? V1 divided by 6, right? V1 divided by 6. V1 is 12, is 2 amps. Alright, next IC is V1 minus V2 over 1, which is, yeah, let's just write V1 and V2. So V1 is 12 minus 6 over 1 is 6 amps. ID V2 is 6 over 3 is another 2 amps. Last one, IE V2 minus 2 over 2, 6 minus 2 over 2, right? So 8 over 2 is 4 amps. Okay, so these are the answers for question A. Last one, question B, you just need to compute the generated power from these voltage sources. So let's say this is source 1, this is source 2, so this is A, right? Put A. B, so PS1 is the generated power at source number 1. So voltage, so the generated power is 44 multiplied by IA, right? But if you are noticing that we have plus sign here and the current is going out, so the sign is negative. Okay, 44 volt times IA, which is 8. So this is equal to 352 watts. How about the power at the second voltage source? We have voltage is 2, but the current is going into the negative sign first from IE. So, but that is equal to this current here, IE, right? Going out from this positive sign, so we still have the negative sign, minus 2 volt times IE, which is 4, so we have minus 8 volts. So the total generated or developed power is, sorry, this will be minus, so minus 352 plus minus 8 is minus 360 watts. Oh yeah, so since I said here that generated power, then I should eliminate the sign, so just like that. Okay, all right, so I hope my explanations are clear. If you have any further questions or my explanations somehow are confusing, then you can always ask me, send me email, or come to my office hour every Tuesday at noon until 2 p.m. Alright, thank you, and I'll see you next time.